Perfect. Okay, welcome to this presentation, Security as Code, a DevSecOps approach. My name is Joseph. I am working with the GitHub Security Lab. We are a security research team that focuses on the open source software. But before that, I was doing security consulting for IBM, advising CISOs. And before I started as a software engineer, I think the highlight of my cybersecurity career so far is a zero-day vulnerability in a top 10 cryptocurrency, where I showed how you can stop transactions that are legitimate randomly and make some people that are progressing the world forward with blockchain innovations to rethink some designs about speed and security. Okay, I'm coming from GitHub, which is where we build software, but we want to shift towards security as well. So let's build from here securely. I want to speak a bit about the GitHub Security Lab because we have some impressive statistics, in my opinion. We have one security vulnerability every 3 days for the past 2.5 years. So it's like 400 zero-day vulnerabilities in open source software that you know and you use as part of your supply chain for the past 2.5 years. And at the same time, we make these workshops, these talks about research we create. We democratize this research to developers, which are people like you, in order to bridge the gap between security and software developers. My personal research for the past month focuses on ChatGPT and GitHub Copilot, and specifically on how we can leverage the knowledge of the whole world, of the community, through products like that, to be distilled and be given in your hands. So we bridge the gap between this stat that is one security expert for every 500 developers. Now, the plan for today is to start speaking about a case study that involves a bit of planets, as you see there. Then we can define security as code. I will do a demo, and this demo is going to be live. I'll be coding on my computer. And the goal for me is for you to leave today with the basics in mind of what is security as code and understand how you can code, how you can codify security. And then we can connect at the end, speak about the future, and answer questions. I will also be here for the rest of the day. So let's start our case study with a company that is called NASA. I expect everybody to know NASA. 10 years ago, this company, it's a client of us, has gone to Mars for the first time with a rover called Curiosity. And it's important for this example to understand how big or small this rover is, like to make it in human-like dimensions. So this is a scientist standing next to a rover. So the goal is for this rover to land on the surface of Mars and do some research based on sensors, carry out some metrics. So in order for the rover to arrive from our planet to this planet, they will need a parachute to make it land safely, okay? And this is code that is very similar to real NASA code. I just simplified this code for the example. And the story I'm gonna tell you is 100% real, Googleable and everything, okay? Does anybody see any problem with this code here that NASA used to fire the thrusters that will then open the parachute for the rover to land on the surface of Mars? Say again? The array length. What specifically? You are correct. Can you elaborate a bit more?
It doesn't check that the array you pass in has the correct length.
OK, that's correct. Thank you. So in line 7, we have an array of 3 elements being introduced here, that when it's passed in here, we are going to have random behavior from element 4, 5, 6, 7 until element 12, because it's going to access elements of the memory that we didn't define. So the problem is that we are going to have random behavior, okay? And someone from the NASA team was like, do you want to check for one last time the code responsible for doing that, for doing the other thing? And one of this code that they wanted to check for one last time was this bit here. So they performed code review at the very last moment, basically, at production, which is the definition of production, like before a rover landing into Mars. And they found this problem. The smart thing that they did, in my opinion, it was not that they decided to check that. They understood that if we have this problem in this snippet, maybe we have it elsewhere. Maybe it's us, maybe it's the way we work, maybe it's our coding style, maybe it's the way we introduce arrays and we pass them into things. That's the smart thing they did, okay? So they were able to understand that this is a problem they have, and they used the tool I'm gonna show today, CodeQL, which stands from Code Query Language, to create a query and find other problems similar to this in their code base. Okay, give me a random guess now. How many other similar problems, variants of this vulnerability did NASA find in their code base? Just give me a number.
2,000.
No, it's lower number. Let's keep it to 2 digits. It's 30, so you are close. Okay, so they find this thing 30 other times, okay? Very similar problem. So one of those 30 other times will possibly throw in the garbage, the effort, time, money that they will use, that they used. They fixed it, and the rover, that's a real tweet, arrived safely in the surface of Mars on the 6th of August, 2012. Okay? That's perfect. This time they gone away with it. Lucky for them. Now, almost 2 years ago, they tried to do the same thing. This time the rover wasn't a rover, was a bit of drone, you know, more fancy. And they did something obviously differently. They have learned from the past. And this is the previous CEO of GitHub that says, DM me directly if you have any problems when you use CodeQL, actions, etc. The smart thing that they did this time is that they put first the developer and the community by using CodeQL. And we say that CodeQL is developer first and community driven for 2 reasons. Let's start from community driven first. Why is community driven? It's community driven because the query that the NASA people wrote to find out those 30 problems, we have it in our code base of queries. So it's something that I can go now in the tool and find it. So when an enterprise like NASA creates a query, they can democratize it with us, and all the rest of enterprises in the world can benefit from this knowledge. Then GitHub, my team, with this one vulnerability every 3 days, many of them are coming from CodeQL, and we make these queries public for people to use. And we also maintain a bug hunting program that we reward people with money when they contribute queries to us. And then developer first. For me, that's the most important one, because the future of security, in our opinion, in the opinion of GitHub, in the opinion of Microsoft, which is the parent company, is developer first, and then is community driven. Why is developer first? We believe that it's developer first because our research shows that developers are the creators, are the center of everything. If they work with security in silos, or they have to exit this tool and go to another tool to pick up something about security, it doesn't scale, it doesn't work. Long term, you are going to have problems in your organizations, and we have research that shows that. We believe that everything should happen inside the text editor. That's why Copilot is inside the text editor. That's why everything we do happens inside a PR, a pull request. We do comments on there, we fix code on there, we see everything inside a pull request, because we believe that this is how the future should develop in order to have proper security. Now, let's introduce security as code. Security as code is defined as the methodology of codifying security decisions that are then shared with other teams. Let's go one step further. how this translates into a normal day-to-day organization. Myself, as a security specialist, I'm going to codify my security knowledge about something. For example, the problem that I showed you with NASA, by writing 3 lines of code. That's what is needed to pick up the NASA problem, okay? When I write that down, it's like law for the rest of the company, okay? Including developers, security teams, etc. When that thing, that knowledge is codified, it's something that both developers and security specialists within our organization can look at and speak the exact same language. Because you read the same thing, you speak the same language. I'm not talking about exploits and threads and the payloads, and you are talking about something in the developer world. Have you experienced this kind of things that I'm talking about? Like, are you aware of the... Perfect. So, CodeQL, why CodeQL? You can query your code like data. It's very similar to SQL. But it's also object-oriented in the sense that you can have these nice things with classes and inheritance, composition, and stuff like that. So when we say describe what to find, not how to find it, you just say, give me that guy standing on a black shirt, black t-shirt. That's it. You don't say you need to go inside, open the door, see around. You just describe what to find. It's logical because it uses operators like and or to find things. Community-driven, we touched on. And loads of templates for productivity. I'm going to use templates on my demo. I was also helped a lot with templates when I get started with this. Templates means that I just change a bit of placeholders, and here it is. It goes straight away. And one bullet point that I would add here, it's, again, Copilot, AI. We are currently doing research on how Copilot can improve CodeQL. I actually published a video on YouTube as well. I was writing CodeQL with Copilot, and I will show you this today in the example at the very end. Because it's going to help you to learn much faster. It's going to make you much more productive. Now, CodeQL is used to query code. So it's not necessarily for security. You can use it to familiarize yourself with a new code base. It's currently supporting these languages here. Rust and Ruby were our latest additions. And when I say currently supporting those languages, I want to clarify that CodeQL is a language itself, but is able to reason, describe things in those languages here. So when you have code in Python, for example, you can find problems, and in the rest of the languages. How does it work behind the scenes? Behind the scenes, your code base becomes an abstract syntax tree, so that it's a relative database for CodeQL to find problems with your code. And that's why you have this powerful thing in your hands to say, for example, give me that specific condition after this for loop in a very descriptive language. And just to be like super accurate, it's a SAST tool. It's a static application security testing tool, similar to SEMGREB and similar to other static analysis tools. And it's not a Dust tool because it doesn't fuzz. It doesn't run your code, and it doesn't give a lot of like inputs in order to find problems. And this is to manage expectations better. Now, you can be a passive user, like I honestly expect this room to be, because I understand that you are developers. Or you can be active users, which is what I'm going to show in the demo. Now, passive users, what is the workflow looking like? You are coding as normal. You push your code, and then you have code scanning running for you, finding problems, showing alerts, explaining exactly what the problem is about. And I want to show you this so that you visualize it. So this is my GitHub account. I go to one of my projects, and it takes 3 clicks to turn it on. CodeQL is free for open source public projects, but has a bit of cost for like licenses that are for enterprise world. So I can go like this. And then this YAML file is ready for me to commit it. And then I'm going to have code scanning created, no actions needed, no CI/CD definitions needed. All is going to be done with you automatically through this YAML file. And you can get a bit fancy here by choosing how much noise you want, how much depth you want for the checks. So for example, the default checks are using the database we have, which includes very polished query sets that have the less possible false positives, and it's very difficult for a query to end up in our query database. We do a lot of testing. Or you can get, for example, based on your use case, if you are a QA person, or if you are a security researcher / hacker / security penetration tester, you can do security extended because your job wants you to have a bit more noise. But as developers, you want to have the less possible false positives. So I would recommend you to just do a commit here. And let me also show you how an alert looks. So now I want you to visualize, to think about the fact that you push your code. And once you push your code, you have some problems. So you go to your security tab, view alerts. Here are some alerts generated by CodeQL. And if I click on one alert, I can see here exactly what the problem is. An explanation of the problem, URLs on official websites to explain the vulnerability pattern, and you see some comments below, some commits, everything happens in this PR. You can create an issue, resolve it, push again, and when you push again, you are gonna know if this is resolved or not. Because the number of alerts should go down in here. And you have a description, use of broken or weak cryptographic hashing algorithm on sensitive data. I was using MD5 here, for example, or SQL injection here. Now, this is for passive users, okay? Users that are gonna want to have a static security check when they push code. I want to go one step further and show you how you can code with it, what active users will do. And as I understood, you are developers here. I know many of you will not use this case, but if your organization in the future is using, for example, CodeQL, you will benefit a lot from understanding how queries look, how are written, what is the mindset behind, because eventually, like I said, you are going to speak the same language with security specialists within your organization. Now, passive users, we showed that. Let's now move to active users. To prepare for our demo, I want to show you a problem with SQL injection. So basically, I'm going to use a code base that is vulnerable to SQL injection, and I want to show you how I can develop a query from scratch to pick it up. This is from XKCD. Is everyone familiar with SQL injection, even at the high level here? I'm going to explain it anyway, just to be on the safe side. As per the meme, you have something like this behind the scenes, a student table that the developer naively assumed that people are going to only pass a name, Cleo in this case. However, since there is no sanitization, they can pass whatever they like. They can drop a table, they can create an admin user, they can steal personal information like addresses of students, card details, etc. Dropping the table is the minimum maybe. So in order to build from scratch a query that is going to pick an SQL injection vulnerability, we need to have a source, the source of the problem. And in this case, the source of the problem is where malicious input enters our code base. In this case, is here. Then we need a sink, which is where the malicious user input is being executed. I want to touch on this because it's very confusing among the community for some reason. What if you have this, just this, and it's never executed? What you have is an unrealized vulnerability. It's not a problem, but it's a problem when the query is being executed, like in here. So when the query is being executed, you have data flow between a source and a sink. This means that Clio semicolon drop table actually flows to query execution, and you have actually an SQL injection vulnerability that is true, true, is positive, positive, is not false, negative, a false, positive. And now I want to show you CodeQL in action by going to a code editor. So here, this is VS Code. Copilot for now is deactivated for me. I don't want to have suggestions. Let's do this at the end. There is an extension on the left called QL from CodeQL by going to extensions. And then here I chose a code base that is vulnerable by default that is called Mobile Shepherd from OWASP. So this code base is essentially looking like this. Think about it as a mobile application in your phone that is running Android. Before you open this mobile application in your phone, it's going to ask you for a username and a password. So this username and the password are going to be passed into a database, and if you are indeed providing the correct credentials, you are being authenticated. So we chose this database on the left. When I say database and code base, I use it interchangeably because of how CodeQL creates your database into your code base into a database in order to be able to query that. And then what we want to do is to start writing code basically in order to pick a problem if any problem exists here. So I'm going to model this problem into a source. I'm going to model a sink. And then I'm going to use a template that is given to me with a few to-dos here to add the source, add the sink, and see if there is actual data flow between a source and a sink. If there is data flow, it means that we have an SQL injection vulnerability. Just to be on the same page, you don't need that. This is for your security experts in your organization and eventually the developers in case that there is a security alert when you push your code and some security person comes and says, you can't deploy this because of this problem. That's why we have this problem. So let's start by the source of the problem. The source of the problem is where malicious user input can get into the program. And in this case, is the username and the password field that accept user input. They accept user input through this method here, getText. So if a hacker is going to hack you, they are going to pass from this stage if they are going to do so from username and password. Let's describe using CodeQL what we want to find. This is an empty file. First of all, since we are doing Java, I want to import the Java standard library so that I can benefit from standard options. And similar to SQL, we have a from, where, and select clause. So in an analogy, it can be from humans in this room, so from a type. I want you to then have a condition where this human is standing, for example, or is wearing a black t-shirt. Select that human. So how this translates into here, it's like this. I want you to give me back the getText method. And to give me back the getText method, you need to start from all methods in the program and then go down to the getText method. So to do that, let's switch this with that. We want to say from all the methods in the program that are accessed, so from method access, which is a type, like human, for example, we can have a variable that is called call, where, let's not use the where now, let's do just select call. So we expect this to give us every single function that is being accessed in our code base. And here you have it on the right. So if I click, for example, here, I can see where this happens. It's a way to query code. At this stage, many people interrupt me and say, OK, yes, you do command find, you do a grep thing. OK, just wait until we come in this one, OK? I'm not here to show you a command find, or I'm not like researching AI in my professional life to do this kind of grep stuff. Now, let's be a bit more specific. Let's put some conditions. The condition we want to have is that we want the getText method, where is the place in the program that user input gets into our code base. And we can benefit from auto-completion as well. So here, we want to go with get method that has a specific name. And here you can see also the object-oriented nature of CodeQL. We are on the package android.widget. The type we are looking for is edit text. And then the specific method name is getText. You also have the chance to be like generic and say any. Use like in the same way you have and, or you have other operators like any. So you get all the places in the program, any place in the program that user input gets into the code base, not just where getText occurs. So we have 3 occurrences of getText. We don't know which of them are malicious, if any of them are malicious. We are going to find out by modeling a sink. The sink is the place in the program where these username and password are going to be passed into a query so that the database behind the mobile app is going to get queried to see if they match existing credentials and for us to be authenticated. So let's visualize this. The sink is where the raw query method is going to be executed in our program, but specifically the first argument. Because the first argument is going to include the query, and the second argument is going to include some other parameters. I've seen in my career many companies, many developers, many security experts that are just saying, yeah, raw query. Yeah, but raw query without specifying specifically which part of it, you have false positives. In this small example, it's very easy to get back 5 results. But in reality, you can have a code base of thousands, tens of thousands of lines, and you are going to get hundreds of results back if you are not specific with what raw query argument you want to query with. So CodeQL gives you the chance to be very specific. And from all the methods in the program, in the same way we came back with get method before, we now want to go one step further and query just for the first argument of the raw query method. Otherwise, security teams are losing valuable, productive time going through false positives because the vast majority of raw query methods is innocent, doesn't cause any problems. And to do that, I'm not going to start from scratch. Here we have the same things that we showed before. So far, this query is going to pick up all the raw query invocations in the program. I want to be a bit more specific, so I'm going to use the AND operator. And I only want to have the argument on the first, on index 0, basically. The argument is another type. In the same way, you have methods being one type, access methods being another type. In the same way, you have block statements in if statements being other types. In this case, we have an expression, which I can call argument or I can call A. The variable name doesn't matter. What is important is the type on the left. So I can call it arg and make this return back when I run this. All the raw query methods of the program where the first variable is set. So we have this and this. Now, it's time to see the real power of the language. Like we said before, you are going to have a vulnerability when data flow exists between a source and a sink. In order to do that, we can use this template here. That, again, I don't know who wrote it. Maybe someone from NASA. I actually also don't care who wrote it because it makes me productive, okay? In the same way we use Stack Overflow, etc. So I want to show you, we can speak a bit about this as well. So these metadata on top are going to help us to visualize better the results. Same with some standard libraries that are imported here. Here is a class that you can also see it extends the tail tracking configuration in order to make us fast, and that's why you have a few overrides. And here you have a constructor statement. In the same way you could construct classes in object-oriented languages. Now, let's fill the to-dos and also show you a more expressive operator, which is called exists. That is gonna, it means, it means, okay, you can say this like that. There exists a method access. We can call it call, such that something happens with this method access, which makes your code even more expressive. So if we copy this here, we can just say that there exists a method access where this method access is the get text method. And because we are working on an abstract syntax tree, we have nodes. And these nodes here are expressions, and we want to find a pathway, any pathway, between the source node and the sync node. If there exists a pathway, it means that the vulnerability, an SQL injection is possible. So I want to say that this node is the call, is the place in the program where user input gets into. And then I want to say that there exists another method access. This time is the raw query method. Method access call. That's it. And we need that as well. And in a few lines of code, we are going to have something that models an SQL injection vulnerability for this specific code. Good news is that you will never start from scratch a query. You are always starting from pre-existing QL queries. Like, for example, in 9 of December 2021, when we had log4shell, my team created within a few hours something similar to this, but the initial document, the initial QL file, wasn't empty. We started from something similar, and we just change a few things here, a few parameters to be able to pick log4shell instances. And then after a few weeks, when you had another variant of CodeQL, we changed a few more, and we had these queries. Now, if we run this, we expect to have true positive SQL injection findings that we can visualize exactly how they occur and what pathways they follow, how they travel in our code base. So we have two SQL injections findings here. Let's start from the first one. So the path of the first one is the following. We have untrusted user input that starts from the username here. It then travels to the login method, where you have a username being checked, a password being checked if they are true. Then on the definition of the login method, and finally, they end up on a query. And then is the other aspect of this presentation that someone does this and says, yes, but yeah, it's very easy, it's just 4 pathways, it's very easy to follow. Yeah, but again, this is a demo. When you have real world code and your code base has millions of lines, good luck in finding those 20 places that this malicious input travels until it reaches the sink. You may be able to find a few, but I've seen people that asking me that. I challenge them and I say, okay, find me the next one. And some of them have missed in the past that the password, in the same way that the username, not the password, so sorry, we are still in the username, travels also through the case that it doesn't exist inside the database. So please compare line 102 with line 116. I've seen people missing that. They only fix one of them, or they think that it's going from 102, but it's also going on 116, which this means that someone can steal from this database, drop this database, do something malicious with that database without being necessarily a user being inside that database, because without having authentication being correct, you can still mess with that code base. So this is the first SQL injection path. And the other one is here. So it starts from the password, it flows down to the login method again when it evaluates to true. Again, we have the other case when it evaluates to false, which is here. And you have two confirmed SQL injection findings. Again, into your day-to-day, I don't expect you to have something like that next to your text editor. You should be using the web interface, like I showed before, in order to understand alerts, fix alerts inside the PR. But it's good for you to understand how you can write CodeQL, what it's about, its object-oriented nature, how you can be very productive with templates, and what differentiates us from our competitors is that we have the community, and of course the fact that we maintain all our previous queries. I can actually show you this as well. So here, I've imported the code. If I close everything, here you have the CodeQL project that is publicly available on GitHub, my demo, my git ignore file, and a README file. So if I expand this one now, you see, okay, obviously dev containers and hidden files. Then you see, for example, C++, C#, Java, JavaScript. If I click on JavaScript, here you have QL, and you can have examples of queries of the past about specific problems, like, for example, decoding after sanitization. So if I click here, I get a template about decoding after sanitization, which means that if I'm someone within an organization, I can change this query, I can duplicate, change a few parameters, and I can pick up something very similar. So what I try to say is that everything is in your hands. And because I promised to show you also the future and what I'm working on right now, I'm spending full time of my time in the past few months working with Copilot and ChatGPT, because Microsoft is also like a main shareholder in ChatGPT. And we also have GitHub Copilot belonging to GitHub. So now I enabled my Copilot here, and I want to show you how you can be using it for CodeQL. On the left, I had an extension called GitHub Copilot Labs. This extension here can, the way that people explain this in the past is that in the same way you edit a picture with filters, like for example, in Photoshop or in Instagram, you have something similar on the left. So you can choose a code block and you can choose to make it readable, or you can fix a bug, or you can make it more robust or list the steps, etc. What I want to show you is how you can get some code explained first with Copilot. So if I highlight the whole of it and I do explain, I expect Copilot to give me a step-by-step explanation of what is this code doing exactly. But because I chose the whole file, I expect to see like a more high-level explanation of the code. So if I put this down, okay, let's stay on the allocated space here. Okay, let's make it bigger. Okay, result. Here is an explanation for the code above. The first line imports the Java library. It provides classes and predicates for analyzing Java code. The second line, and it goes like step by step about each line. If I highlight just this block and I go explain, it goes into more depth about those specific, that specific block. It tells you more about it, provides examples about it, so you're understanding into more detail. So the override predicate is source is used to declare the source of the data flow, and you have like even an explanation here about what is everything. And at the same way, you can have the explain code. You can have the code does the following. This is more useful when you do, for example, when you have loops. And maybe this loop has a problem. You can go in more detail. Code does the following in English and show example code. It can show you another example to better understand the code. Like, for example, a simplified version of it. So this is an example for calling the function like this. You can do that and go in a bit more detail. That's the first thing you can use. The other thing is you can choose to make it like more readable, to clean it, or you have a custom action that does something specific. But you can also write code, okay? So if I come here, I delete everything. I'm using Vim, yeah, perfect. And I put a comment, come on. And I say, what do you want to describe in a code base? Just give you an example. Like an if statement, anything you like. Let's keep it open.
Algorithm complexity?
With CodeQL. Like, for example, give me back.
Yeah, give me the algorithmic complexity of 2 for loops.
That's more suitable for ChatGPT, to be fully honest with you. So, OK, let's try. Why not? Give me the algorithmic complexity. No, that's more like of the following loop. But I'm expecting to have, OK, I have this now. We are in a QL statement. So this, OK, let's keep it like that. N to the power of 3. Yeah. So I was looking after a different example, but this is a very good example for something else. So before that, let's do this. Give me the algorithm complexity of the following loop. So let's do explain code, ask Copilot. Let's see if it comes back. You never know. OK, here's explanation of it. We have a loop with 3 nested loops, each of which iterates n times. The total number of iterations is n to the power of 3. OK, we are good. Let's do something more on the coding side. Like, for example, I want to describe, give me all the empty if statements in a program. If you have an empty if statement, it's a problem, no? OK, let's see. So import C++, OK. OK, let's be more in Java. OK, import Java. Import simultaneous tracking. Import data flow path graph. Let's help a bit here. OK, that's good. Class if, empty if, so it gives you a class that extends a configuration. An empty if constructor is an empty if. Give us a bit more. You override the is source of a problem. So there exists an if statement such that this if statement, when you get the then block of the if statement, the number of statements of that then should be 0. You see the expressiveness of the language, right? And also, this if statement should have an as statement. I'm not sure about that. I'm not going to pretend that is correct, OK? I don't know what is the as. I'm going to look up about it later. So what is missing here is to do a query. Like, for example, from this empty if class, where you have the variable config, and you imported everything, where this has flow between the source and the sink, give me back that, which is going to give me eventually all the if statements in the program that are empty. I wish I had Copilot when I started learning CodeQL to explain the code for me, to do all these nice things for me. What I showed you is not a selling point for us, because it's still, we are researching if it's powerful, if it's actually giving back things that are helpful. What I'm trying to show you is the future. Because when I speak in a conference like this, In reality, I'm working on something that is 6 months ahead, 1 year ahead. I want to show you what I'm working on right now. So right now, I'm evaluating if this is actually something that can be sold and add value to a company, or it's something that you think you are buying from us, but in reality, it doesn't help you. And at the same time, I'm working a lot with ChatGPT and other use cases that I'm confident I will be able to show you in the future in NDC security. So for today, and after having a look at the future, I want to summarize that CodeQL has the taint tracking and data flow functionality that makes it powerful with the ability to visualize things. It's a language that is extensible and flexible because you can be very specific, you can get queries of the past, you can do whatever you like. You can build on top of existing queries, benefit from the community, and Copilot is, as you saw, the real example on stage entering the game. That is very exciting. So if you are interested to learn CodeQL and you have some problems and you want to speak with people that are using it every day, we have a Slack community that you can get into by using this URL here. And some references that I found useful when I started my journey with CodeQL 1 year ago, 1 year and 2 months ago, was the official CodeQL.com website, and then some CTFs that give you the answers of the queries. And finally, if you want to connect, we publish all our research in GH at Security Lab on Twitter with videos that I create, like shorts. I show these kind of cool things in YouTube. And my name is Joseph. You can find me in @JKCSO pretty much everywhere. Thank you. We have time for Q&A, and I'm also like around. Yes?
Is CodeQL GitHub exclusive?
Yes. So it is. The reason is, the full story is that CodeQL is coming from a startup company called Semol that GitHub acquired in 2018. This company had a 10-year-old journey before their acquisition. And then Microsoft acquired GitHub a few months later. So the way it works is that it's only within GitHub. So if your repo, for example, is in GitLab or somewhere else, you can't really use CodeQL. But if you are in GitHub, you can use it for free as someone who is an open source maintainer or maintains, for example, your company maintains a public repository for people to contribute in open source. If you are in private, like an enterprise, there's a cost per licensed user that is writing CodeQL like I wrote here. In reality, I'm not familiar with the selling price and everything. I'm not a seller. I'm focusing on the open source community, but if you want, I can make you in contact with the right person within the organization.
Is Microsoft planning on adding this to Azure?
100% yes, and it's actually on, but on a staff ship wave right now, and we are scaling with Azure, and yeah, we have a push towards that. Yeah.
Do you have a roadmap for support for other languages?
Yes, it's public. I'm not sure what is coming, to be honest, in terms of languages themselves. I've seen lately in the roadmap that they try to reduce false positives with machine learning in a way that is not like the usual way. They are having inspirations from some other things that is very interesting, and I'm confident that it's going to be very useful. And the other thing that is coming in the roadmap is that you are not going to even need 3 clicks to create what I've shown as passive user, the YAML file. It's going to be 1 click, and everything is going to happen like straight away. In terms of languages, I'm not sure what is coming. Since we have time, I can go through some other frequently asked questions. A lot of people ask me, what about false positives? Yes, obviously, we are doing our best to have this right noise between false positives and things that are correct. You don't want to miss something that is actually vulnerable. But I guarantee that something that ends up in the query set of CodeQL and assess your code about vulnerabilities is as polished as possible. That's the #1 thing I'm getting asked about CodeQL. And the other thing I'm getting asked is about, okay, so SameGrep, what is different, or these other code scanning tools? For us, it's not about competition, it's about what we bring in the game. And we think that we have a very strong community. Like NASA did that with our product 10 years ago. And all these years, these query sets are being getting into our database, and we now have Copilot as well. So we believe that we have a very polished query set that is inspired from enterprise, hubbers, I mean GitHub employees, we call it hubbers, and bug hunters as well. And anything else you want to ask, like general security question, not about CodeQL, I'm more than happy to answer. I'll be around. And it's a pleasure to be in Norway. It's my first time here. It's also my first time in NDC security. And I hope in the future I can show you like way cooler stuff that are coming in the world of AI, more use cases, and speak about different things as well. Not necessarily like GitHub products, because my team is independent and we can assess anything, including open source products, open source tools. We are independent researchers doing security research, contributing to the world of open source. So thanks again, and you can find me outside for everything, any question you have. Thanks so much.